Good afternoon, everyone, and thank you for coming to my talk. My name is Anders Heilsberg. I am a technical fellow at Microsoft, the chief architect of the C# programming language. And I'm here to talk about the future of C#, at least as far as we can see it. I wanted to just sort of start with a little historical perspective about C#. It's interesting. It's actually December marks the 10th anniversary of the inception of C#. We started the C# design group in late December of '98. And here we are, 10 years later, 3 releases later. The first release of C# was, of course, all about like building a new language for managed code. C# 2.0 then, to me, was about adding all of the features that we didn't have time to do in 1.0 because we had to ship. And when you have to build a whole new language, it takes a while to put it together. C# 3.0 was, I would say, our first opportunity to really think deeply about new things to do in the programming language. And we seized on this thing called LINQ, or Language Integrated Query, worked hard on solving the impedance mismatch between general purpose programming languages and databases. And I think we managed to make a lot of progress there and ended up actually also incorporating a bunch of functional programming features into the language as a result of that. And so today I'm here now to talk about what comes next, which, it's C# 4.0. That shouldn't be so surprising. And even a little bit of a peek of what comes after that. But before we take an actual look at C# 4, I wanted to just show a few slides that sort of try to outline the thinking that has gone behind this coming release of C# and the ones that go after it. What are the trends, what are the factors in the industry that shape our thinking about where we're going with C#? I think they fall into 3 large buckets, if you will. The first one being sort of this move that we see towards more declarative styles of programming. The next one being the sort of resurgence that we've seen over the last few years of dynamic programming languages and how that influences us. And then, last but not least, the coming multi-core inflection point, if you will, but certainly, concurrency is getting increasingly important for us as programming language designers because every CPU these days, or every desktop these days has more than one CPU now. I think the thing that to me is interesting about these trends too is that the uber trend of it all, if you will, is that I think the classical taxonomies of programming languages are starting to break down, and where traditionally we would categorize a language as being object-oriented or functional or dynamic or structured or whatever, we're really increasingly seeing languages borrow from each other. And I really think the new paradigm, in a sense, is multi-paradigm. C# is already, in many ways, a multi-paradigm programming language. We obviously are very object-oriented, but with C# 3.0, you could argue that C# certainly has become a functional programming language as well, because we indeed have all of the sort of cornerstones of what a functional programming language needs. And I think we're going to see more and more of that as we go forward. I'll talk a little bit about these, and then we'll get to the actual C# 4.0. When I say declarative programming, I mean that we are increasingly seeing a shift from the traditional imperative programming styles that we all probably day-to-day practice and that lots of students have been taught, and that really computer science in at least mainstream has been about for the last 40 years or so. When we write code in the imperative style of programming, our programs are, of course, about what we want done, but they are also in excruciating detail about how we want it done. here, declare a variable, then we have an if statement and a for loop, and for I equals 1 to 10, do this and that and the other. And in many ways, it becomes hard to see the forest for the trees, you know, when we write programs. We, in a sense, over-specified the solution to the problem. And that, well, first of all, can make programming tedious, but second, the problem it creates is that it's very hard for the execution infrastructure to be smart about how to execute the program most efficiently given the hardware that you have available, for example. Let's say that you were writing a program that needs to sort some data you have in memory or group it or whatever, and you might write that by newing up a dictionary and sitting in a for loop and doing or calling a sort method or whatever, and by the time this program gets compiled, the JIT compiler can't see the forest for the trees, you know, and there are side effects everywhere in the program, and really it has no choice but to just execute it stepwise as you wrote it. And there's no way that it could automatically parallelize execution of the program. If instead you program at a higher level, like LINQ, for example, where you're saying what you want done, it's all being type checked, but you're calling things like group by, order by, et cetera, then we stand a much better chance of being smart about executing those programs, and we indeed can even execute them in parallel. So the move towards declarative programming, I think, is one that we're going to see more and more of. I think there are a couple of big things happening there. There's a lot of talk in the industry about domain-specific languages. There's lots of talk about functional programming. I'd say C# and 3.0 was sort of our first foray into that, and you're going to see us do more of that over time. Second one of these trends is this dynamic versus static tug-of-war that in a sense has been ongoing ever since programming languages were invented. I have on this slide, you know, some of the advantages of dynamic languages, some of the advantages of static languages, and lots of religious debates about which is better. The reality is that both have good qualities, and the reality is that you really want attributes of both. It is, again, it speaks to this multi-paradigm thing. It's really hard to choose today what language to use. People are clearly being very productive in languages like Python and Ruby, and so it's not right for us to snicker at them and go, well, it's dynamically typed, you know, it can't possibly be correct, you know, and when in reality, real applications are being built that way. So I think over time here, we're going to see languages borrow from each other. Indeed, we're seeing it already. Lots of dynamic languages are striving to introduce static typing, and we'll talk about what we're doing in C# 4.0 also here in the dynamic space. Finally, concurrency. I sort of have this elephant here because concurrency, in a sense, is the elephant in the room for a couple of reasons. One is, you know, concurrency and parallelism is hard, and Moore's law has, in a sense, allowed us to stick our heads in the sand for decades because it's just delivered not just faster, not just higher transistor density, but also higher clock rates year after year. Now that has stopped. I don't know if you've noticed it, but you know, we seem to have leveled out at around 2.5 gigahertz or so, and it's really sort of hard to get. There's certainly no 5 gigahertz machines out there that I know of. So all of a sudden, you know, Moore's law is still working in creating higher transistor densities. Indeed, it looks like for at least the next 10 years, we're going to continue to scale the circuits down, but they're not going to get any faster. Instead, we're going to get more CPUs. And now the onus is upon us to figure out what that means for programming, you know, because it's no, you know, lots of CPUs don't help you if your application is written as a single logical thread that can only start here and run to completion. The thing that's interesting, actually, well, the other thing about concurrency is, and this is, you know, from the fable of the 6 blind men and the elephant, is that concurrency is there's not one single silver bullet that's just going to fix it and make everything concurrent. It's not like there's just going to be a /parallel switch on the compiler and then everything is hunky-dory. Well, people tried that, but you know, it's never worked. The reality is that concurrent applications have to be written to be concurrent, and you have to think about it. And there are many different ways of thinking about it. And the thing that I actually find fascinating about what's happening with multicore is that in spite of the many different ways we have had to think about concurrency, like processes and threads and asynchronous agents and da-da-da-da-da, the multicore phenomenon is actually, in a sense, calling into focus a different kind of concurrency, one that we have not traditionally focused on so much. The solutions that we have in our operating systems or programming tools today for concurrency are largely about coarse-grained concurrency, where you either have multiple processes that you're running, or you have threads, a couple of background threads, and so. But it's all very coarse-grained, and it's really, in a sense, about doing multiple logical things on fewer CPUs than you have logical tasks. But if you think about what's happening with many cores, it's actually exactly the reverse. It's about taking single logical bodies of work and running them on multiple CPUs. And, that has been around in the HPC space before, but it's really nothing that we've focused on a whole lot. So what we need to do as language designers is find easy and understandable ways for people to, in a sense, decompose their applications into multiple units of work that can then be executed in parallel. Okay, so, and I should say here, one of the things that we're focusing on there in .NET is this thing called the parallel extensions for the .NET framework. We have several talks here at the conference. I urge you to go see. It's some work that I'm really happy about what they've done. And one of the things they do in the parallel extensions for .NET is they make great use of all of the new functional features that we added to C# and C# 3.0, like lambdas and so forth. And in a sense, with the expressiveness we gained in C# 3.0, it becomes possible almost to create new statements in the language. And indeed, the parallel extensions for .NET have a parallel.for method that takes, the lower and the upper count, and then it takes a lambda expression, which is the body of code you want executed in parallel. And if you squint, it almost looks like a parallel for each statement in the language. But it's simply because we have enough expressiveness in the language to do this. And so the wonderful thing about that is they can go experiment with concurrent APIs without us having to commit to specific language syntax until we found the right solution to the problem. But of course, there are things we need to think about, like immutable objects, purity of functions, isolation, and so forth. And those are things that weigh heavily on our minds day to day. Okay, another, not really a trend here, but more a slide just to sort of talk a little bit about C# versus VB and the way we have evolved these two languages over time. Ever since the inception of .NET, we have, in a sense, labored hard to try to position one versus the other. What's it going to be? Should I program in VB? Should I program in C#? And we've had all sorts of explanations, but the reality is that for many people, it's about what you did before. If you programmed in VB6, VB.NET is a natural evolution for you. If you were a C++ programmer, C# is a natural evolution. And any of this sort of artificial differentiation that we've tried to do between the products, every time we try to do a different feature in one, the other group wants it too. The reality is co-evolution is the right way to evolve these languages. And what we're doing sort of in our product strategy here is a subtle shift towards simply recognizing the reality of the situation. And we are aiming to co-evolve the languages in the sense that whenever we introduce new features in one, we will work hard to put it in the other as well. Now, you shouldn't take this to mean that in the same way. So I'm not going to promise you that C#, for example, will have XML literals or whatever, but because there's another great way of doing it through the Link to XML API. But we will indeed labor hard to co-evolve the two languages so we can sort of just diffuse this whole one versus the other situation. Okay, so back to the evolution of C#, and here the rest of my talk now will be about C# 4.0, the next release of C#, and then a sneak peek at the end of some even more future work that we're doing. Now, the major theme in C# 4.0, I would say, is dynamic programming. And I mean dynamic in the broadest sense of the word here. I don't necessarily just mean dynamic typing. I mean talking to anything that isn't statically typed to be a .NET class. And there are lots of things in the world out there that aren't .NET classes. And in C# 4.0, this is sort of the broad umbrella around the language. So let's take a look at what that boils down to in terms of features. And they fall into 4 large buckets. One called dynamically typed objects, optional and named parameters, which is a long-standing request that we've had from the community. Greatly improved COM interoperability and optional and named parameters help us a lot there. And then finally, co and contravariants. And we'll now go into more detail on each of those in the next few slides. Now, some of you may be familiar with some work that a fellow named Jim Huguenin and his team are doing. Jim is the architect of Iron Python and also the architect of the dynamic language runtime. And the dynamic language runtime is a piece of technology that unifies dynamic programming on the .NET platform. If you think about the CLR has been about building a common platform for statically typed languages on the Microsoft infrastructure, if you will. And this platform has dynamic capabilities. Sure, you can do reflection and reflection emit and so forth, but it was never really sort of intended to be its main goal in life, and there were some features missing. The dynamic language runtime is about adding those features and that same unification on top of the CLR. So think of it as an extension of the CLR that unifies dynamic programming on top of .NET. So the dynamic language runtime consists of a bunch of sort of core infrastructure like expression trees, which actually are the same expression trees that you see in LINQ, even grown up to also now support statements. It's about dispatching dynamic invocations to a variety of different binders. It's about call side catching to get efficiency, because if a dynamic call goes to the same place 1,000 times, we can just do the resolution once and then cache the result of that. Now, on top of the dynamic language runtime, we have already built, Iron Python, Iron Ruby. Those are out there, available today for you to play with. The new thing here is that we are actually in C# and VB also adding support for using the dynamic language runtime. And certainly we expect others to do that in their languages as well. Now, underneath the dynamic language runtime then, we have binders that allow us to talk to a variety of different technologies. Of course, there's a binder that allows us to do dynamic invocation on just .NET objects, but there's also one that allows us to talk to JavaScript in Silverlight, or we're building one of those. There's one that allows us to talk to Python, one that allows us to talk to Ruby, and one that allows us to talk to COM. And so in a sense, with all of these different binders, we can get a single programming experience for talking to all of these environments that are, in a sense, not statically typed .NET classes. So let's look at what that looks like. Let's say I have myself here a nice traditional statically typed piece of code. I have a calculator class, and I have a method that can return myself a calculator, and you see I call getCalculator, stored in a variable, and because that variable is statically typed to be of type calculator, and because, say, our calculator has an add method, it's now possible for me to call add and produce the sum of two numbers. Now let's say that the calculator is not a statically typed .NET class. It might be something that was written in COM. It might have been written in Iron Python or Ruby. It might be written in JavaScript or whatever. Now, for me to talk to it, all of a sudden gets very painful. Let's say that it is indeed a .NET class, but I don't know its exact class. I'm dynamically loading some code and then discovering what its type is. Well, then I would call getCalculator, then I'd have to get its type, then I'd have to call type.invoke member of add and pass a bunch of enums and some flags and what have you, and then finally get the result and convert that back to an int. But if the thing that I wanted to talk to was a JavaScript object, well, then I'd have to go through similar incantations, but different. because there's no unification of these APIs. So here I now have to get a script object and call invoke on that dude and then also convert the result back. But basically, for each of these different dynamic domains, we have a different programming experience, and that makes it very hard to unify the code. With C# 4.0, it becomes possible to write the code this way. You simply declare a variable whose static type is dynamic. So you... Yes, it's clever, isn't it? So you can statically type things to be dynamic. You can say, hey, this guy will hold a reference to something, and when I do operations on them, I want them done dynamically as opposed to statically. And that means that when I say dot on something that is typed to be dynamic, it means dynamic invocation of an add method in this case. And when I assign, and whenever you call something whenever you call a dynamic method, the result is always dynamic as well. And if you assign a dynamic to something, it is a dynamic conversion to that type. Okay, so now you might go, well, gosh, Anders, have you gone stark raving mad? I mean, haven't you taught us for 10 years that static programming is the right and only way? And now here you are, being heretical. Well, I think the thing that's interesting is that I am not saying here that you should go rewrite all your code to be dynamic. I am a deep, deep believer in the power of static typing, the capabilities you get through statement completion and refactoring and compile time errors and improved performance. These are all directly attributable to static typing, and I think it's a good thing, and that's not going to change. However, there are an increasing number of things that are important to talk to in your applications that are not statically typed. And now we can, in a sense, argue, well, should we make it painful to talk to it, or should we work on making it easier? And that's really what I'm talking about here. For example, if you have to talk to JavaScript from a Silverlight piece of code, why shouldn't that look like regular code? If you have to talk to Python or Ruby, or for that matter, if you load up an XML document, which inherently, well, if you don't have schema for it, it's untyped. Why should it be, .getElement or whatever, as opposed to just dotting into the XML, for example? Or if I have a data reader, why is it datareader.getInt of 0 and whatever, as opposed to just dotting into it? Yes, it is not strongly typed, but it's still valid in many, many application scenarios. And that's really sort of what we're working towards here. Okay, so the way this dynamic guy works, then, is that we have a new keyword. Well, it's one of those pseudo keywords, just like var and whatever, that's a keyword only in certain cases. But we have a new keyword called dynamic, and you can set the compile time type. You can declare variables of type dynamic, and that means that at compile time their type is dynamic. Now, at runtime, of course, these variables also have a type. In this particular case here, the first one has the runtime type system.int32. And dynamic really is sort of about marrying these two things. But the way you should think about dynamic is that it's just like object. Anything can be assigned to a dynamic. It's really, and the way we encode it in metadata is it's a system.object, but then with an attribute on it that says, oh, but by the way, with dynamic semantics. Now, when an operand one or more operands in an operation are of type dynamic, what happens is that member selection gets deferred to runtime. So instead of at compile time figuring out where a call or a property access or whatever is going to go, we defer it to runtime, just like a dynamic programming language would do. And then at runtime, what we do is we take the actual runtime type and we substitute that for all of the variables whose type was dynamic, and then we do normal overload resolution, just as if it was compile time, if you will. So we just move that resolution to compile time. And so we can resolve overloaded operators and overloaded method calls and so forth. And then the result of any dynamic operation is itself dynamic. So the thing continues, if you will. Let's look at how this works in practice. Let's, for example, take the the math class that's in system, you know, there's an overloaded method called apps that gets you the absolute value of a value, and it is overloaded for a variety of data types. Now, in statically typed code, I might declare myself a variable of type double, and then I might call math.apps of x, and this just causes the compiler at compile time to choose the most specific implementation for my operand, which is the one that takes a double. I could write this using dynamic typing also. I might have a dynamic x that I, you know, in this case here, I have it right here, right? But I mean, I might have gotten that from somewhere else, and now I want to compute apps of that thing, but I don't know what its type is going to be. However, by typing it as dynamic, I can defer method resolution to runtime. So it will pick the same method here, but it will do that resolution at runtime. And if my x had been an int instead of a double, it would have picked the int method apps, if you see what I'm saying. So it's really, it's the same mechanism, but moved to runtime. Okay, so let's try and take a look at some of this stuff in action. I have several demos here to show you how this whoops, gotta get, it's this machine here, sorry, I got a couple of them. Let me switch to it. Here we go. Okay, so on this machine, let me actually first run it. I have a little Silverlight application that just loads up some customers and then allows me to view their data. And the app also integrates a virtual earth control to show where this particular customer is located with a push pin, and I can sort of hover, and the push pin's data has been set to the customer's data, and so forth. So let's look at how this guy is built. You'll see that we have a start page where we have a little, we reference the virtual earth control, which is written in JavaScript, and then we have some JavaScript code that we've written to manipulate the virtual earth control, and we're going to call that from C# and you know, poke in values in the map. So if we look at the C# code, we here get ourselves our customers, and then we call through the Silverlight interoperability mechanism, we call invoke of create map, and you see we have to reference that in quotes. And then whenever we change the selection, we call set property of title, and then we invoke update map in JavaScript. And so here you sort of see it's kind of a funny experience in the sense that, you know, all the C# code is nice and beautiful to look at, and all of the interop kind of looks funky. So what I also have on this machine is a little prototype of a binder for JavaScript. And I've already referenced that in my project here. So what I'm going to do now is try to grab different code for these HTML document and HTML window objects, which represent the HTML document and the HTML window that I'm operating within. And I'm going to type those. I'm going to use a little asDynamic extension method that we've implemented that can do dispatch to these guys through dynamic typing. Now with this in place, I can actually now go modify my code to just be win.createMap, like so. I can do doc.title equals, etc., etc. And I can do win.updateMap, like so. And now my code actually looks like real code, right? And if I run it, you'll see that that we get the code runs and does the same thing, basically. Okay, now you saw me also show you that some of this code was written in JavaScript, and indeed, now that we have all these dynamic capabilities, why would we even write it in JavaScript? We could actually write it in C#. In fact, it's striking how similar the two languages are. So what I might just do is copy, and then let me go to my C# code here and paste it. Whoops, I didn't copy, I guess. Let's go here, say copy, go here, and say paste. And now we get a few errors here. Okay, bar, well, yep, we can't, we're going to type it as dynamic, like so. And then our functions here, well, we have to say void instead of function. It's really actually a very mechanical mapping you go through. And then our variables, well, they have to have a type, but it can be dynamic. Like so. And then the last little thing is the new operator, which, what we're newing up here are not .NET classes. We're newing up JavaScript objects, right? So we're actually still working on the syntax for that. So right now you call this pseudo.new method and then follow it with the class name. This will change in the final product, but I mean, doesn't really matter. You see that it's possible to do it. And that's really all I have to do. Now, of course, I have to prove to you that this code is running. So when we set the data for the, oops, sorry, not right there. Here, when we set the title, let's set it to from C# plus the name of the customer. And let's try and run. And here we are, but this time, yeah, well, we get the same result, but if we hover, oops, I guess we did, oh, yes, I see. I forgot to actually make the calls go to my methods here. So let's get rid of that. There we go, and this. Now let's try. And click, click, let's hover, and we see from C#. So now this actually ran in C#. Thank you. Okay, that was demo number 1 here. I talked about how this allows you to talk to Python as well. So let's look at some Python interop here. Indeed, let me grab another little project. I just have an empty program, and I have some code written in Python. Here, in fact, it's the same code that we were looking at earlier on the slide. I have a little getCalculator method, and then I have a calculator class with an add that returns a calculator instance, and then I have an add method that adds 2 values. So let me try and actually use that from C#. So I've imported ironpython.hosting here, and let me grab a little piece of code here to first create the Python runtime. So I tell it to load up the file called calculator.py, and now I can say dynamic calc equals Python dot, and you'll note here that there is no statement completion because this thing is dynamic. So I can basically write anything I want here. Calculator. So here I called the getCalculator method, and let's actually then use something or do something with it. I might write a little for loop here, for example. Let's see, here we go, where I call calc.add 10 times and then write out the result. And here you'll notice this is a dynamic call. And indeed, the type of this is dynamic. You see calc is dynamic, so the add invocation here is dynamic. So if we run, hopefully we'll see numbers from 100 to 109. So that was C# calling Python. Now the thing that's interesting is that the method I'm calling into a dynamically typed language, so I can pass it any argument type I care to. I could pass it decimal here, for example, and then say treat the sum as decimal. And if we run, you'll see that I'm calling the same method, but now I'm getting decimal results because Python is loosely typed and will operate on ints or decimals or whatever. In fact, since it uses the dynamic language runtime, it'll operate on anything that implements an operator plus. So I could change this to be a date time. And then call calc.add of, let's say, datetime.today, and then add to that, let's say, timespan dot from days of I. So here I'm adding a time span to a date time, but since there's an operator plus implemented for that, that's what Python will actually end up invoking. And so again, you see here how I get great interoperability and I get the native capabilities of whoever I am invoking, if you will. Okay, so back to the slides. So you saw me here invoke dynamic code in JavaScript, in Python, I could have invoked in Ruby and whatever. The way this works under the covers, if you will, is that we have an interface called iDynamicObject that an object can implement. And when an object implements iDynamicObject, it can participate in resolution of how method calls and property accesses and so forth get resolved. Now, we have, in the dynamic language runtime, is sort of pre-wired to know about .NET objects and COM objects and so forth, but then dynamic languages can implement their own objects, and indeed you can implement your own objects in C# as well that resolve dynamic lookup, like properties and methods and so forth. And you do that by inheriting from a method, a class called dynamicObject that implements the iDynamicObject interface. And I'm going to show you just what that looks like in code here. So let's try to load up another project. Oh, I'm sorry. Switch machines. There we go. Back to this machine here. And then let's try and load up our little dynamic object demo here. Indeed, I have nothing in my app here. I'm going to build it again. You see I'm importing system.dynamic, which is the namespace where dynamic object is declared. And let's say I want to build myself a property bag. So I might implement a class bag, which is a dynamic object that implements its own get and set member property lookup. So when I dot on this thing and say .name or .id or .price or whatever, I implement the lookup of the member. And I do it simply by maintaining a dictionary from string to object inside my bag. That's all I need to do to implement a dynamic object that's usable from C#, but equally usable from Python, Ruby, or any of the dynamic languages on top of the DLR. So let's see what it looks like in use. I might say here dynamic bag or dynamic x equals a new up a bag. And you see what I do here is I new up a bag, but then I store it as type dynamic. And now whenever I say dot on it, I'm not talking about the statically declared members on that thing. I'm talking about dynamically dispatching to it and having it resolve member lookup. And now I can simply go, since it's really just a thin wrapper around a dictionary, I can just start adding values to it. So x.id equals 1, 2, 3, 4, 5. Let's say x dot, okay, why is it complaining about that? Okay, x dot name equals, let's say, lawnmower. X dot category equals gardening. X dot price equals, I don't know, $7.95.50, for example. And now, well, let's also implement some code to output this guy. So I'm going to implement a little toXML method that just news up an XML element and walks over the dictionary and just picks out names and values and then makes that into my XML. And then my toString I can implement in terms of that. And so now I can just do console.writeLine of x here, for example. And if we run, you'll see that I have myself a nice little bag with ID, name, and so forth. So a nice little dynamic object. Oh, thank you. Let's say that I wanted to implement a little nicer output of this console.writeLine of, whoops, let's say the price of 1 plus x dot name is plus x dot price. Like so, for example. So here I am actually accessing the properties, and that'll call my getMember method on my dynamic object. So if we run, you'll see again the price of one lawnmower is blah, blah, blah. Now, let me actually try and refactor this guy out as a separate method here. So we'll say refactor extract method. We'll call that writeBag, like so. And you'll see that it is statically typed to be dynamic because x's type is dynamic. So now I have a method that will take a dynamic, which could be any object that I care to pass to it, and then it'll fetch its name and price properties in whatever way is appropriate for that kind of object to do that. So I might, for example, declare myself a shovel equals new, and then say name equals shovel, comma, price equals $14.95, like so. So use an anonymous type, which is a strongly typed object now that has two properties, name and price, and I've got an instance of that called shovel, and then let me try to pass that to write back. So write back of shovel, like so, and let's try and run. And here you see now that I accessed my dynamic object, which went through the dictionary and so forth that I had just created, but likewise the dynamic language runtime can dispatch to a statically typed guy as long as he has a name and a price property. Then, you know, we will resolve the dispatch. In a sense, this is native support for duck typing, if you will. Not that I'm advocating duck typing, but you know, some people find that very useful, and it does indeed have its good uses. Okay, let's get back to the slides here. And that was sort of a quick run through the new dynamic capabilities. Next feature I want to talk about is optional name parameters. It's very typical in the .NET libraries to have methods that take many arguments, and it's very typical also that you want to default some of those to some default values. For example, let's say I have an open text file method here that takes 4 arguments. A typical pattern in .NET and user code is that you declare a primary implementation that takes all the arguments, and then you declare a bunch of secondary overloads that start chopping off arguments and call the primary method with default values. Now, with C# 4.0, you can do this simply by declaring default values on the parameters. So, thank you. Yes, customers have beaten us to a pulp over this thing, and I've finally had to relent. But you'll see actually that it has other meaningful uses than just this, and it's important for other reasons. But it is now possible to have optional parameters on methods, and indeed this has been supported in .NET ever since the beginning because VB has optional parameters, and so you can attribute this to co-evolution or whatever, customer feedback, but it now is possible then to call this open text file method by omitting things, and when you omit things, we automatically pass the default values. We also support named arguments, so you can actually now specify by name which argument you're passing here. And here you see how I now pick one of the optional ones, the very last one, by saying buffer size : whatever. Now, named arguments must be last. They must follow all the positional arguments when you specify them in calls, and the compiler will automatically just make a regular call. There's actually no compiler overhead associated with this. This is just syntactic convenience. Here's a really crazy one, you know, where I call purely by specifying named arguments, and I specify them out of order, which indeed is permitted, and they get evaluated in the order I write them, in case you have side effects, which I would not recommend. However, non-optional arguments must always be specified, either positionally or by name, if you will. Okay, now it comes time for me to do the big mea culpa. Raise your hand if any of you have ever written this piece of code or something like it. Way too many, yes. This is the sad state of affairs when it comes to COM interoperability, talking to the office automation model through C#. And it's, for historical reasons, ended up being this way. When we first built .NET, there were certain things that we felt were not appropriate in the platform, if you will, such as optional arguments and name parameters and whatever, and APIs that have 16 or 30 arguments that must be specified by name and so forth. And so we omitted them from the platform. However, the office automation libraries already existed, and it's a huge cost to customers and ourselves and everybody to go rewrite them, so they have never been rewritten, and we've sort of had this stalemate of, you know, of poor interoperability. So my apologies. This is no longer necessary. In C# 4.0, ta-da, you get to actually write doc.sym. Yes, isn't it amazing? Took us 10 years to get back to where we were. Now, okay. Indeed, one of the main features of C# 4.0 is improved COM interoperability. I'll go as far as saying vastly improved COM interoperability. We basically have fixed all of the issues that are in there. So the code you get to write now in C# looks just like VBA code or Office Automation code. It looks the way it was intended to look. And it's really an amalgam of, first of all, our support for optional and named parameters, also special support for index properties in COM interop code, an optional ref modifier. You can omit a ref, again, only when you're talking to COM. We're not making this a language feature, but you can omit ref in those cases. And then we have two interesting features. One is, and these are features you can either turn on or off. In old projects, they're off by default, but in new projects, they'll be on by default. One is an automatic mapping of the type object to the type dynamic whenever you import a COM interface, which means that all methods that take or return object now take dynamic, which really is what they were intended to do always, because COM, it is a dynamic experience, and really you are passing dynamic things to and from. The other is a feature that we in-house called no PIA, no primary interop assembly. It is the ability for the compiler and the CLR to automatically embed interoperability types, so you do not need the primary interop assembly when you run the final app. We just encode the GUIDs and whatever and little bits of code, and that's it. So, thank you. So let's take a look at what this actually looks like in the real world. Let's go back to this one here. And let me load up an Office interop application here. Here we have a C# 3.0 Office interop app. Let me first run it, actually. What it does is it runs a little link query for the number of the processes that are running on the machine, orders them by working set descending, takes the top 10, sticks them into an Excel spreadsheet, and then uses the graph wizard to make a graph of it, and then it pastes that into a Word document. So let's try and run this. And we'll see Excel fire up, and we'll populate it with the results of the query, and then we will finally plunk that into Word, and lo and behold, dev-env is a hog, but we knew that. Okay. Let's get rid of this stuff here. Okay. Now, this code has basically all of the bells and whistles of the oddities of COM interop pre-C# 4.0. Here, for example, I'm calling excel.cells, which returns something of type object that I must then cast to excel.range so I can fetch out its value property. That we can now do. Whoops. I'll just go cut and paste here. That now looks like this, the way it is supposed to. Likewise, in the for loop here where we're setting the cell values, we can just shorten it down to what it should look like. Here, where we're calling excel.cells and we cast it to range, well, we don't actually need to do that anymore, because this thing returns something of type dynamic, because that's how we import the metadata now, and something of type dynamic can be assigned to something that's more strongly typed, and then we will dynamically do the conversion, so this just converts to excel.range. The chart here, the creation code for that, we can now use optional arguments, so no more type.missing, type.missing, type.missing. Did I say type.missing? Now you simply get to say it the way that it should be said. Likewise, with the chart wizard guy here, lots of type.missings in that one, we get to just say source and title and rely on default values for the rest. And down here we have probably the beauty of all of them, var missing equals type.missing, and then pass ref missing, ref missing, ref missing, it's just insane. all goes away. There we go. Bye-bye. Boom. And let's try and run. And, well, it compiled, and obviously it'll produce the same result. But as you can see, if we go back here and look at the code here, this actually looks like the code was intended to look. And that really is sort of the value of the feature. There are also some interesting things here. Indeed, here with Excel.cells returns a dynamic, and when we say dot value, it is simply dynamically dispatched to dot value, but it is just completely integrated because a lot of the office automation models have this funny kind of typing. We call it peter out typing. They sort of are strongly typed, but then they peter out and become dynamic, and then you can sort of continue dynamically. And as you can see, we support that now. Okay, back to slides here. Co and contravariance, the last of the features in the new language features. Here's a piece of code. This could have been written on .NET 1.0 where I knew up myself an array of strings, and then I call a method called process of strings. And process is actually declared to take an object array. And because .NET arrays are covariant, it is possible for me to pass a string array as a less derived object array. Now, the thing that's interesting about this feature is that it's sort of, well, I guess it intuitively would seem to be a safe and fine thing to do, right? But .NET arrays are maybe covariant, but they're not safely covariant. Indeed, let's say that the process method was implemented as follows: object.0 equals hello, and object sub1 equals new button, which will compile with no errors, but will fail at runtime with a dynamic type check. Basically, what happens here is that for arrays of reference types, every assignment to an element has a dynamic check that checks that what you're assigning is actually of the actual runtime type of the array. That, of course, adds some overhead. It's not all that dramatic, but it defeats safety and type checking, and that is somewhat problematic. Now, if I had written this using generics, instead say list of string here, and then call process of strings, and let's say for process to be maximally applicable, I have written it as an IEnumerable of objects. Well, this would give me a compile time error here. Seeing strings does not implement IEnumerable of object. It implements IEnumerable of string, but since generics up until now have been invariant, those two types are not compatible. Now with C# 4.0, they do become compatible. So C# 4.0 supports safe co and contravariance. And I'll show you what I mean by safe here. If you think about this piece of code here, in a sense, when I call the process method, why is it that it's safe? Well, it's because IEnumerable is a read-only interface. There's no way through IEnumerable to poke new elements into the list, and therefore it is safe to treat something more derived as something less derived because I'm just fetching them out, and the fact that I get more derived things out and then treat them as less derived is obviously a safe thing, right? But if you think about it, that's actually, you know, the cornerstone here of type safety, if you will. And the way we implement safe co and contravariant in .NET is, here you see the original declarations of IEnumerable as they exist in C# 3.0 and previously, and they have a type argument t, and t, you know, has no decorations on it. In C# 4.0, it becomes possible to indicate co or contravariance by placing either an out or an in modifier on the type argument. So when I say out here, it means covariant. T is to be treated covariantly. And the way this works from a safety perspective is that T gets restricted to output positions only. So in the interface, it is possible for me only to use T in output positions. That is, it can only be used as the result of a method call or the result of a property accessor. It cannot be a parameter. A parameter could not be of type T because that would not be safely covariant. We would have to inject dynamic type checks. Now, because T is declared to be covariant, I can now call a method getStrings that returns an IEnumerable of strings, and then take my strings and assign it to an IEnumerable of object. And the compiler knows that this is safe. There's nothing here that could go wrong because we're only getting them out, not putting them in. So when things are covariant, things can be treated as less derived. That's really but we do have contravariants too. If you now take an interface like iComparer of T that takes two T's, well, we can mark that as being contravariant by using the in modifier, and that restricts T now to input positions only. So T can only be used as method parameters or write-only properties. In this case here, they're arguments. And now I can get myself, say, an object comparer, a thing that can compare two objects. And now I can safely assign that to string comparer, a thing that compares two strings, because certainly I can pass strings in as object arguments and it's safe. You sort of intuitively can see how that's safe. So contravariant things can be treated as more derived safely. Okay, so just sort of summarizing what variant support we have in C# 4.0. Variance is supported for interface and delegate types, not for other types. So it's restricted to interfaces. Technically, the thing we implement is known as statically checked definition site variants. If you go look at the computer science around like co and contravariants, Java wildcards, for example, implement use site variants also where you can specify when you declare a variable or parameter, the covariance you want, but it gets to be very complicated. And I think that it seems to me there's agreement that probably definition site is the right way to go. Just like arrays, value types are always invariant. So just as an int array cannot be treated as an object array because they're representationally different, you can't treat an IEnumerable of int as an IEnumerable of object. And finally, ref and out parameters need an invariant type, and really it's because they're both input and output, if you will. Okay, that, I think, well, sorry, one more slide here. So now that C# supports variants, we have decorated some of the interfaces in the .NET framework with variance annotations. So here are the ones that are affected. The ones that are really important is IEnumerable, iQueryable, and then in the delegates category, the func and action delegates have had variance annotations put on them. And in a sense, the way you should think about all this stuff is that it's all very technically interesting, but really, in a sense, it allows you to do things in your code that previously you were surprised you couldn't do. And that's really the good way to think about it. It's like, why can't I treat an IEnumerable string as an object? Well, now you can. And really, for most uses, you don't have to understand any more than that when it comes to variance, because I know it hurts sometimes to try and grok it. Okay, so those are the features in C# 4.0, which is part of the next Visual Studio train. But of course, we're not going to be done with C# 4.0. We're already thinking about what goes beyond that, and I wanted to give you a sneak peek of some of our thinking here as it relates to that. One of the things that we increasingly see in the industry and when we build our apps is use of metaprogramming. We see it in many different ways. People do, for example, dynamic code generation. Literally every enterprise app that people build today somehow relies on dynamically generated code, be it ASP.NET or Entity Framework or Link to SQL or what have you. They all do code generation. We also use reflection.emit to generate code and so forth. And all of these technologies are kind of painful to use. Part of what we're missing there is, a modern approach to metaprogramming on the .NET platform. If you look at least from my perspective, one of the things that's driving the success of a product like Ruby on Rails or a project like Ruby on Rails is not so much the fact that it's a dynamically typed language, but rather the fact that it is a very good meta-programming language. It allows you to do, dynamically generated code and evals and so forth. And that's what gives them the succinctness in the kinds of apps you can write. So one of the things that we are working on going further out than C# 4.0 is a rewrite of our C# compiler into managed code. Now, our compiler, for historical reasons, was written in C++, mostly because we had to write the compiler so we could write the platform, and then once we had it, we didn't throw it away. But increasingly, that thing has sort of become a bit of a millstone around our necks because it's a very classical compiler. It takes source files in and out comes assemblies on the other side. But everything in there is a black box. You don't get to participate in that process. Now, what we want to do going forward, and the reason we're rewriting the compiler, is we want to sort of open up the box and give people access to, the things that go on inside the compiler, such that we can enable scenarios like meta-programming, interactive or REPLs or interactive loops, such that we can make it much easier to embed C# in domain-specific languages like workflow documents and whatever, where you have little snippets of codes or rules that you want to dynamically evaluate or compile. And also, we need desperately an object model for C# source code, so you can write refactorings and whatever, and an open ecosystem for that. And all of that comes down to we need a compiler that isn't just a black box. And that's something that we've been at work on now for about a year or so. And I wanted to give you just a sneak peek preview of some of the things you can do with that. So let me advance here, and let's go to this other machine here. And I'm going to try and play a little with writing some dynamically compiled C# code. So once we have the compiler in managed code, you can actually use the compiler as a service now, as an API. We're turning the compiler into an API. You can give it a string containing C# code, and it'll give you back either executable assembly, or it could give you back statement trees that you can then walk and transform and then turn into code and so forth. Now, what I'm going to play with here is a simplified version of that, just a little C# evaluator object here that I'm whoops, on the wrong machine. I'm newing it up. If we look at the declaration of C# evaluator, you see that it has two collections, references and usings, and then it has an eval method that takes a program as a string and returns an evaluation result, which in turn is either the object value resulting from evaluating that C# or a list of errors. And it uses in turn a C# compiler. If we look at that one, there's all sorts of stuff in here, capabilities of compiling and so forth. But let's look at what it looks like to play with this guy. So here I new myself an evaluator, and I add a using of the system namespace. And now I can just say stuff like ev.eval of for int I equals 0, I less than 10, I plus plus, console.writeLine of, say, I times I, like so. And then let's try and run this. And lo and behold, we have a little program dynamically compiled there. Thank you. Thank you. Now, let's try to define, for example, a square method also here. Turn this into first declare int square of int x, return x times x, and then eval calling square 10 times, for example, and we should get, ideally, the same result. Now, the thing that's interesting about this evaluator, though, it's like C# here is becoming a dynamic capability, right? And when I use the evaluator here, I'm generating the code and then running it right away in the same executing CLR. So one thing I could, for example, do is I could first add here, let's see, a reference to system.core so that I can reference the func types. And then let me try to generate instead here a delegate to, gets a little funky here, but so what I'm going to go eval here is, well, actually, let's just do it like so, new func, like that. Okay, so the code that I'm going to dynamically evaluate is create a delegate to square, and that's going to be the result of my dynamic evaluation. And then I'm going to take that value and cast it to func of increment, and now I'm holding a delegate to the dynamically compiled code. And then I'm going to call that statically from my for loop here through the delegate, right? So let's try and run that. And sure, I get the same result again. So it's truly... All right. Okay, let me end by just having a little more fun here and create an actual read eval print loop. So I'm going to paste in a little class called user interface thread. Don't worry about what it does. It's just starts a background thread and allows me to evaluate or run code on that thread, and that thread has a message pump. So if the code creates windows, then those windows will have a message pump. That's really the only purpose of that guy. Now let me add some references and some usings to my evaluator here. So I'm just going to reference a bunch of assemblies, and then I'm going to add a bunch of using clauses. And then let me paste in a little REPL loop here, where I new up my UI thread there. Now I sit in a loop here, and I just print out a prompt, read some code. If the user wrote some code, and if it is not complete, then ask for more until it is complete, and then run it on the UI thread by calling eval and writing out the result. So let's try and run. And now we can start typing, 1 plus 3 math.sign 1 console.writeLine. In fact, I actually have a few little snippets that I wanted to try and fire off here in my evaluator. So let's do this, and then let's tile these two windows here, like so. Okay, so let's try to run a for loop. Here we go. Let's declare a little factorial function. There we go. And then now we can call our function. What's factorial 5? What's factorial 10? Let's do a print method that encapsulates console.writeLine so we can be more lazy and just say print. And then let's for each the Windows directory here, for example, and see what are all the files that are in the Windows directory, or how many processes are running on this box. Way too many. What are the 5 largest ones? So that's a little link query. Well, there's dev end again. Okay, let's try something really crazy. Let's new up a Windows form. There. And actually, so that's why I had to do the UI thread. And you see that it's topmost, so it stays on top then. Let's set its background image. Whoops. Here. There to be something. Let's add a button to it. There we go. And now I can click the button, but nothing happens. Oh, but let's add an event handler that prints hello world. And now let's click and look at this. All right, and let's close it. There we go. Okay, so this gives you sort of an idea of some of the stuff that we're noodling around with. We're going to try and ship this as soon as we can because it's darn useful, as you can see. But I can't promise you when exactly that will be. Okay, whoops, I went the wrong way there. Sorry about that. That actually is the end of my talk here. I wanted to plug my own wares. we have the latest version of the C# programming language reference book out. The two things that have happened in this edition of the book is that it is now everything has been integrated into one reference as opposed to sections that describe C# 1.0, or whatever. It didn't really scale for 3.04. So now we have it all integrated. And the most important thing, I think, is that it's been annotated by several industry icons. So we have lots of annotations in the book that explain why things are the way they are. Okay, other than that, I wanted to point you at some related sessions here. There's a good session, the deep dive session on dynamic languages in .NET. That's Jim Hugenen's session. I'd urge you to go see that one. Alex Turner has a session on interoperability. Paul Vick is going to talk about, and Lucian are going to talk about Visual Basic. We have a panel on the future of programming languages on Wednesday. I'm going to be on that with some other industry folks. Luca Bolognese on Thursday has a talk on F# that also I am very enamored with, so if you get a chance, go see that. We have samples and white papers for C# 4.0 up on our website, and of course the Developer Center as well. And that's it, basically, but I would be happy to take some Q&A here at the end of the session, and also please fill out an eval. So please go ahead. Thank you.